Hi and welcome to Geeks for Geeks. Today we would be discussing the problem find duplicates rows in a binary matrix. So this problem has two sides of it. We would discuss it. But before that, let me just explain you the problem in brief. So basically you are given something a binary matrix. What do I mean by binary matrix? A matrix which only consists of zeros and ones. Okay, this is something like this, and you need to find the duplicate rows. Okay, so now let us just draw the very first test case and you would have an idea. The very first test case is very evident enough. Let's draw the second test case. We have 1 0 0, we have 1 0 0 again, and we have 0 0 0, and we have 0 0 0. Here it is told find the row numbers. In the bracket it is 0 indexed, so we would take hold of that. This is 0, this is 1, this is 2, this is third row, and if you see, the first row is getting repeated with the 0th row. So I can say the very first row, and then we have the third row. So these two rows, that is why 1 and 3 is the answer itself. So now if you see, this is a binary matrix and every number can be represented in its binary format. So if the size of the array would have been 31 multiplied by 31, that is, if the size of the array would have been small, then you would have accommodated, or let's say 64 also. So if it had been big, you would had, like, if you just see what is the value of this. The value of this is only 0 1 2, that is 4. The value of this is again 4. So whenever we see a same number again, we would just say that, and then this is equal to 0, this is equal to 0, we are seeing the same number again. So if the size of the matrix is small, we can just find the decimal value of it and we can use the decimal value of it. But here if you see, the constraints are very large, that is 10 to the power 3, so we can't really build a number that big. To be honest, we can do it by using something, the concept of big integers or something, but that won't come into picture here. Here we can't treat it as a decimal. We can't just take up the binary thing and treat it as a decimal. So basically what we need to do here is that we need to find a kind of same string. So when it comes to string hashing, so we need to hash out the string hashing. Then you need to use map. Like, you can just have all the row as a map in the map, and if we are seeing the same value again, then this you would just have that. This is not the intended solution in an interview, but in an online judge this would work flawlessly because no one would check the implementation. But if this is given in an interview, the interviewer would directly tell you, can you do this without using any inbuilt function or libraries? And you would be coming to the conclusion that you can't really use something known as mapping or something. So we need to hash the string. Okay, we need to hash strings. So whenever we see string hashing and matching, whenever we see up this string hashing and matching, whenever we see up this, the first thing that should pop in your mind is nothing but trie. The trie data structure. What is this trie data structure? I would suggest that you have an idea and then come to this problem. That would give you more glimpse of this. But still, I would just teach what is this all about. So we start off with the root value. This is the root value. Then after that, let's just hash the very first string, which is 1 0 0. So we would have 1, and then we would have 0, and then we have 0 again. Then we want to hash the second value. So from root we would go to 1. Okay, and here we would also mark it 0, and then we would mark it as, yes, this is a leaf value. Okay, then we would come to 1 0 0 again. So we would come to 1, then 0, then 0, and here it is ending. So if the end of the current string, that is 100 again, this is the end, and the previous any string has also an end, then we would say yes, this is true. So what I meant to say is, let's say we have something like, you can't really visualize this in a binary string. Let's just take the value in something else. Let's say we have something like this. Let's say this is the root, and from root we are emerging, let's say A. Suppose we want to hash A, B, C, D. Then we want to hash A, B, C. Then again A, B, C, D, E. And then we would hash A, B, C, D. At this point we need to say that yes, a same string has been seen again. So see how this would work. We would first have A, B. A, then we would come to B, we would come to B, then we would come to C, and then we would come to D. At this point we would say, yes, this is a leaf, else everything would be 0. Everything at everyone where it would be 0. This is how the first string would be inserted into the trie. Next we want to insert ABC. So we would go to A is already present, we would move to B, we would move to C. At this point this ends here, so this is the end of any other string, so we would have it as 1. Now we have hashed ABC also. See how ABC, if we go to ABC, then C would be marked what 1. ABCD is also present, so D is marked as 1. Then ABCDE. So now we would first come to A, then B, then C, then D, and then we have something known as E. And here we would again mark as 1. Then we have ABCD. So if you just observe, we would go to A, then B, and then C, and then D. Yes, we came here till this point, and if this point is equal to 1, then this value is present. If this value would have been 0, then this is not present. And we would use up this. So here, if you hash strings, then it can have A, B, C, D, that is all 26 letters, but here we need to handle only 0 and 1. So from each node, there would be only 2 emerging children, that is 0 and 1. Okay, so we would make up a trie, we would start inserting it. So let's just have it. Let's move to the implementation now. So very first we would have as struct, and then we have something known as trie. First is the boolean leaf. At each node there would be a leaf value, that is this boolean value that is there. At each node there is a boolean value that is associated at each node. So we have bool leaf. Okay. Then we have again trie, and there would emerge 2 children. So I would say children and then 2. Okay. Now we need to make a function or a kind of method which would help this. So this is this. So for Java programmers, this is like a class, and these would be the methods. So try get new node. Okay. If a new node is called, first we would make up a node from that point. Okay. So try star node is equals to new try. We would make up a new instance or an object of a class. Okay. Then we would say node dash children 0 is equal to node dash children 1. Both would be equal to null. That is, both the children are not present, but they are present as null. And then we would say node dash leaf. Initially it is false. And then we would return this node. Done. Then we would need a function to insert the node, which would return 1 if there is a successful insertion, return false if it is already present, so the insertion was not successful. So searching and inserting can be done in the same part. So insert try, so I'll just make it as uppercase. Okay, so now insert node would accept a try with pass by reference head, and then we would have vector of int and arr comma int n. That is the whole array, like 100. We need to insert this whole string, kind of string. Suppose it is a string. So first we would get a copy of head, try star current is equals to head. Now we would start iterating on the elements. For int I is less than n and I plus plus. Okay, so if current dash children dash a of I, let's just make it a of I is equal to null, then make a new children, current of children dash a of I is equal to new node. What do I mean by this? Let's just have this. See, let's say there was already a root, and from there we have A, B, C. Suppose it is already present and I want to insert A, B, D. So first we would go to A. If it is already present, no issues, just move forward. If it is already present, no issues, move forward. But D is not present. So if after B, D is not present, then we would make a new node for D and initially mark everything to null. Okay. Now we would make the changes. Okay, new node. So there would be two children which would be made to null and false is equals to false. Okay. And then we would just move forward. Current is equals to current dash children of A of I. Done. At the end, okay, this needs to be outside. We are making a loop, but we are moving forward in all cases. Like if there exists a node, move down. If there doesn't exist a node, make a node and then move down. So moving down is always an option. That is why I have taken it in the generalized block. Okay, like the block which would happen every time. Then if current dash leaf is true, that means like it was already true, like it was ABC and beside C 1 was present, beside C 1 was present, so it is already present. So we would return 0, that a successful insertion didn't happen, it was already present. If not, current dash leaf would be made to true and we would return a successful insertion. And then this would solve the purpose. First we would make the instance of the class, or here the struct. So we would have new node. So a new node is now done. Now we would insert for. So here I would write M N, and this is the bigger matrix, so I would just name it as mat. Okay, so for int I is equals to 0, I is less than M and I plus plus. So if a successful insertion didn't happen at any point, that is the head remains the same and mat of I remains the same and N remains the same. If a successful insertion didn't happen, then answer dot push back I. and we would be returning the answer. Now let us just compare it and see how many errors are we making. Seems like no error is being made and this is working fine. And yes, we were able to solve up this problem. So that's it for today. The only learning out of this was the knowledge of try and the application of try. These are the two things that you are gaining out of this. So if you liked up this video, like it. If you don't like up this video, please share a feedback so that I can improve and improvise on myself. That's it for today. This is me, Siddharth Hazra, signing off. Thank you.